Hi everybody. We're going to be looking at for loops today. We just did do while loops. Before that, we did while loops. We also looked at infinite loops and a little bit about convergence. We're not going to be being fancy about convergence, but when you're writing a while loop, just make sure that you reason about your code. Make sure it's going to actually stop when you want it to stop, at least. A for loop forces it to stop, which is kind of nice. You're probably wondering, why is there a bowl of chili on the front of this slide? Well, I like this metaphor. Maybe you don't. When I'm cooking at home, my wife and I sort of have different approaches to cooking. She likes recipes. When she finds a recipe, she sticks with it. She finds her recipe. She doesn't goof around with it. She doesn't improvise a little bit. She doesn't play with the spices at all. When she makes she makes chili at home in a slow cooker. It's exactly a half cup of this. It's exactly 2 tablespoons of this. It's these exact measurements for every part of it. And for years before meeting her, years and years and years, I improvised every single pot of chili I ever made. I improvise my spaghetti sauce. I improvise my lasagna. I improvise everything I do. Hell, I improvised my meal last night. I'm going to improvise my meal tonight. Right? I like that little bit of play, that little playfulness that you get in the kitchen. But when I'm playing around the kitchen, I don't know if that thing's going to turn out or not. In fact, half the time I get inedible garbage, right? Well, maybe not half the time, but a lot of the times, my chili is not as good one time as the time before. I never get actually dead on to the same recipe each and every time. Because there's so much play, it's easy to screw things up. So, my wife making chili is like a for loop. She's following the recipe. What's his end goal? When you put all the ingredients in, you are done. My chili, on the other hand, is like a while loop. When are you done? Well, I'm going to try a little bit more of this. Oh, taste a little bit. Oh, no, I need a bit more chili powder. Okay, and put a little bit of chili powder. Oh, I need a bit of paprika. Oh, I need a little bit. When does it stop? You don't know. It's indeterminate when you stop adding spices. You can easily screw it up by keep on adding spices and never getting it quite right. If you follow a recipe, it's going to be right. The for loop is our recipe. When I have a for loop, it is easily the most common kind of looping mechanism in C and C++ at least, and Java, and every other language that looks like them, because it prevents you from screwing yourself up. It prevents you from making an infinite loop by accident, because everybody, when I was programming video games back in the early 2000s, I know I'm old, when I was making kids games back in the early 2000s, I was cranking out like 5,000 lines of code a day or more. If you're making that much code in the run of a single day, which is not really that crazy, it's fairly crazy though, you are going to screw something up somewhere. You're going to have a syntax error somewhere. The for loop prevents you from doing stupid little things like you would with a while loop. So if you are, especially if you have a lack of attention to detail like yours truly, then the for loop is your friend. It prevents you from, missing the increment of that particular variable, right? It will stop. It's there to make your life easier, even if it looks a little crazy at first. So here is actually the syntax, and the syntax looks terrifying. Well, at least I think it does. And then the next slide will hopefully calm some of you down. So the for loop has the syntax of, I have some kind of initialization code. I have a semicolon. I have the condition that makes me loop around again and again and again. Well, while this condition is true, I will keep looping, just like a while loop. I have a semicolon. I have some kind of update event. So every time through the loop, at the end of my loop, I will do this particular thing right here. Technically, you can leave off any one of those things. I don't think you can leave off the condition, but you can leave off the initialization, you can leave off the update, and it's still a for loop. In fact, I can make a for loop that looks exactly like a while loop, acts exactly like a while loop. All I have is no initialization, the condition that stops it, no update. That is a while loop. So I have some kind of initialization code, some kind of condition, some kind of update, and then I have the stuff that I'm looping over, just like a while loop. It'll be easier if I actually show you this in action, though. So I like to point out the preamble, don't hurt your head, and sorry about the little syntax here. Let's put it, I left the ink on there, not realizing that I was going to have the words popping up. So my for loop is designed to simplify your thinking, and it's only useful if it's simplifying your thinking. So here's the code. Here is what I will blindly write for every single damn for loop that I write. There's been a couple cases when I haven't, but they're very, very, very rare. So if you want to memorize anything in this course, this is one of the few places I say, yeah, go ahead and memorize it. Put it on your cheat sheet. That's great. You do not want to hurt your head thinking about how to compose your for loop. Every one of my for loops look like this. For int I is equal to 0, I is less than some stopping condition. The number of times I want to loop around. This is just the number of times I want to loop around. I plus plus. Every single one of my for loops look like this. Every single step, all my code that I'm going to do over and over and over again goes in there. And by the way, this variable I is available in here. So every time through the loop, I'll know what loop number I'm on. It's the value I. And yes, we use the variable I. I've been saying don't use variables like I, J, K, X, Y, right? It looks like a bad variable name, but historically, everyone that sees an I goes, oh, that's what that is. That's my index. That's my counter. Okay. Why this format? Well, that's going to become a little bit more obvious very, very soon. But the idea here is this will go exactly size number of times through the loop. Period. No thinking. I look at this, I go, I see a 0, I see size, less than, strictly less than, size, I see an I++, that is my format, and it will do it exactly size number of times through this loop. And there's a reason it looks like this, but if you start getting all cutesy, it's going to be a lot harder to reason about your code. So this just says loop around size number of times. All right, so here I am looping around size number of times. So I'm going to have to put some ink in here. I don't think I have things popping up, so let's look at this. What I would normally do is I would normally make int I is equal to 0 here, not just I is equal to 0. You don't have to make a new variable, but if I say int I is equal to 0 here, I make a brand new variable called I the first time I start doing my for loop, and the I stays around until my for loop is over. Okay, so what is my initial I value? It's actually equal to value 0. Great. And I'm going to print out, the output is I is equal to 0, new line. I now loop around again. I'm going to go around I++, so I becomes 1. I go, is I less, and then I go, is I less than 3? Well, it's 1, so yes, it is less than 3. So I will go in through my loop again. I is equal to 1. Loop around is, I'm going to increment my I value. I is equal to 2. Is 2 less than 3? Yes, it is. Loop around again. I is equal to 2. All right. Loop around again. I++, I becomes 3. And then is 3 less than 3? No, it's not. I'm done. Notice how many outputs I did. I did 3. I didn't output the number 3, but I went from 0 to 2 and then stopped. I did 3 outputs, exactly 3 outputs, starting at position 0. And you're probably wondering, what the heck? So I like to point out the fact that computer scientists are kind of weird in that way. If you ask a lot of computer scientists to count things, they will count this way. 0, 1, 2, 3, 4. All right. We count from 0, and it makes no sense to anyone that has not been programming for a while, but there is a very, very good reason for that. We count from 0 just because it makes our life easier, being efficiently lazy. We'll see why in a second. But essentially, we are doing this because it helps us with the math and how we figure out where we are in an array. Oh, wait, let's talk about arrays. So an array is a big chunk of data. It is a big bunch of blocks of data. That's all it is. Originally, they were contiguous. It was asking the system, hey, give me 20 different integers, and it gives you a chunk of memory the size of 20 integers, right? And you can just use it whatever way you want. So it might look like this. At this particular address, here are my 6 different numbers. I could ask for an array of 6 numbers. This is the address in space where this is stored in memory. So this is the memory address for this block of 6 integers. And I'm going to count those integers 0, 1, 2, 3, 4, 5, 6. Actually, sorry, 7 different. This is an array of size 7. Why? 0 to 6 means I have 7 elements. The reason I want to do this is because if I go to position 0, what do? I take my address, I add 0. Oh, I'm pointing at position 0. I take my address, add 1, I'm pointing at position 1. I take my address, add 2, I point there. It's just because it allows the math to be easier. That's why we count from 0. It's confusing to a lot of people, but that's every single language, or almost every language. Python does, JavaScript does, Java, C++, C. Almost every language I can think of that has an array counts from 0. It just, you get used to it, but you have to get yourself used to it. All right, but we're going to deep dive into this soon. So here's my array. It has a grand total of 7 elements: position 0, position 1, position 2, position 3, position 4, position 5, position 6. Right? There are 7 in total, positions 0 to 6. And I can access an individual element by, so I'm making a new array. We're going to get to this very, very soon in another set of lectures, but here's an array called mynums, which has 7 elements, these 7 elements. If I say, go to the 4th one of those elements and set the value to 32, what happens? I go to position 4, index 4, and set the value to 32. This value here, instead of 5, which was here, it is now the value 32. I can go to individual elements by just giving the number. And let me get element 2. So here's printf of element 2 is, and I can just get position 2. It should be 3.7. This should be element 2 is 3.7. It's a position 2. So my nums at position 2, whatever the value in that bucket is. That's an array. The reason I need to go over this is because arrays are so highly related to a for loop. Again, notice we count from 0. Our arrays count from 0, which is why our for loops start at 0, because it is the first position in our array, no matter what. You get so used to it that because of the decision to make arrays starting at position 0, our for loops start at 0, which is the first position in our array. And I don't have to worry about, like, is it less than or equal to size? No, it's always less than size. The size of the array is 7 in our previous example. The last valid element in our array is position 6. 6 is less than 7. And as soon as I is equal to 7, I'm not in a valid position in my array anymore. The array goes from 0 to size minus 1. Those are the array indices that are available to us. That's why we don't do a less than or equal to. We just say it is strictly less than. If my index was greater than or equal to size, or my index was less than 0, well, I'm outside of my array. I'm pointing somewhere else. I got a major error on my hands. So if I go back here, I'm either pointing out around here, or I'm pointing out around on the other side over here. Both cases, that's bad. I don't want to be here. I don't want to be here. I want to make sure I have a valid value. The valid values are between 0 and the size minus 1. Always. So that's why my for loop looks like this. It is always between 0 and size minus 1, and then it stops. The for loop is designed that way. I don't memorize anything. I memorize this one pattern because it works with all my arrays. And I use for loops predominantly for arrays. I use them all sorts of places, and other places, but in arrays especially, it's extremely useful. That's why they're the classic combination. That's why I want to make sure we go over them at the same time. So let's figure out how I already have the example here. Let's sum up this array of values, right? So I have, or I can sum up the first, so here are my nums, or this is example my nums, but we can use the other one from before. What am I going to do here? So let's go over, do I have, let me see if I want to use, let's use x, oh, x nums is going to be size 10, a size. Let's use the other one. So what were my values here? 2.0, 9.2, 3.7. 3.7. What other things do I have here? 17.4, 5.0. Negative 187 and 0. All right. My sum starts off with the value 0. I am then going to, I'm going to take my first value. I'm going to add 2 to the sum. So the sum 2.0. I go through the loop again one more time, another time. I'm now at position 1. I is equal to 1. So let's put I. All right. Next time through the loop, I is equal, now is, we're going to also delete this thing off. I is now equal to 1. The sum is equal to the value at position 1. I is equal to 1. Value at position 1, 9.2, plus 2.0. Right? So that is now 11.2. Loop around again. My I is equal to 2. I then say 11.2 plus 3.7, and please correct me if I end up screwing up the math here. That's 14.9. Is it 14.9? Yeah, sure, 14.9, right? And I can loop around again. Oh, the basic math is going to get unruly soon. All right, so 14.9 plus 17.4. All right, so that is, what is it, 20, 31, 32.3? Let's say it's 32.3, and if my basic math is wrong, please forgive me. All right. I'm at position 4 now. 0, 1, 2, 3, 4. All right, and I keep on, the next loop around is going to be position 4, which is, I'm going to add 5. Then position 5, I'm going to add this, and then position 6, I'm going to add 0. And at the end of the day, the sum will be this plus this plus this plus this plus this plus this. All of these numbers added together. Okay. And so we can walk down my array, and at each step I can do some operation. So try this out on your own. We're going to do a little exercise right now. Try and make a for loop that outputs the number on the let's say just the number on the screen. So in the case of, if I'm using some array called xnums, there's 10 elements in total, it would output 2, 3, 4, 5, 1, negative 1, 17, 4, 9, 6. Then write a function or make a for loop that finds the index of the smallest element. So the smallest element ends up being this negative 1 should be the smallest element. So I should, this thing for exercise 2, I should return whatever this index is here. 0, 1, 2, 3, 4, 5. It'll be index 5. So I can put this in here, this int xnums on the line above, and then write my for loop to see how it works. Okay. The part of the point is, it shouldn't matter what the array looks like, the size of the array. If you pass me an array of numbers, this summation function will work. As long as I know the size of the array and you give me the array itself, I can sum up all the elements in the array. I don't have to change my code at all. And I don't have to worry about having an infinite loop. The for loop handles that. It starts at 0, ends at the size I++. Done. And I can get individual elements from my array using the index I. The I stands for index. Okay, so give exercise 1 and exercise 2 a try right now and see how well you do. Do I actually have I think the quiz is actually going to be one of exercise 1 or exercise 2. So, might be a good idea to give that a try because you should have a quiz available for you right now. Okay, here's our for loops yet again. Notice I intentionally left on the annotation from earlier. Why? Because because I need to show what all these parts are. With my for loop, I have an initialization statement. This is the I is equal to 0 part. I have some kind of stopping condition that I check each and every time through the loop. So if I is greater than or equal to the size, I would stop and exit the loop. Otherwise, I'm going to go into the body of my for loop, do whatever's inside the for loop. And then when I'm done, I++. So I check to see if I stop, do the body, increment I, loop around again. I don't have to reinitialize ever again after the first time. I'm just checking to see if I stop, do the body, I++. That is how my for loops are designed. They're designed so that you don't have to worry about accidentally forgetting this I++ or the counter plus, like I did with the for loop, or with the while loop, sorry. For loops can even be nested. In fact, they are often nested. If I have to deal with an array of arrays, or if I have to go through, let's say, an image on the screen. That's called, you can say an image on the screen is a bitmap. It is a series of pixels, a series of colors in a two-dimensional table. Bitmap. If I want to go through every one of those pixels, I go along a row, and then I go up one row, and go along that next row, and I go along the next row. I have a column and an index, and I use 2 for loops to go through every single one of those pixels. As a general rule for me, I don't get cute. Don't get cute. You'll just hurt yourself. Like, you're going to screw up something if you try and get like, oh, I can save a little bit of time, or I don't want to use I, J, and K. No, just by convention, for our indices, we have I for a for loop, J for a for loop within a for loop, K for a for loop within a for loop within a, I don't think I've ever gone below K, ever, right? But the idea is, by convention, I can go I, J, K, L, however many for loops I have. I normally make a brand new variable here, rather than just, setting I to equal 0. But there's no limitations on how things are initialized. In fact, I can do a lot of crazy things. We're going to look at some of the crazy things. But I want to remind you, keep it simple, stupid is the policy, right? If you try and get all fancy pants with your code, it's going to be harder for you to read it. It's going to be harder for your TA to read it. It's going to be harder for you to debug it. So just keep it simple. Your for loop looks like int I is equal to 0. I is less than whatever size is I++. Just if you keep it simple, you can manage for loops. But if you start getting all playing around with the format a little bit, it's going to be harder for you to understand. And by the way, just as another little side effect, if you use a variable called I anywhere, and it's not for an index in a for loop, it's wrong. It's not actually wrong. The compiler will let you do it. That's not a problem. But every single programmer that looks at this, when they see an I, with the exception of the printf statement, I guess, right? When they see just an I by itself, everybody thinks it's an index in a for loop. Anything other than that, they're going to be very confused. It's like calling your variable x and not having it do with x, y, and z coordinate systems, right? Or calling your variable count and has nothing to do with counting, right? It makes no sense. I, J, K are exclusively used for loops. So here is me getting all cutesy, and please don't, as a general rule. So here's my initializing. I could initialize something to 0. I can initialize it to some variable j, let's say. I can initialize it to 1. I can initialize 2 variables even if I want to. Notice, until I get to that semicolon, that first semicolon, this is part of the initialization. I'm initializing multiple things. This part is the condition. This part after the second semicolon is every time through the loop, what do I increment? So I can instantiate 3 variables, I, j, and m, to be 3 different values if I wanted to. I've never once done that in my life, but you could. They're all perfectly fine. They will compile, but they're also crappy. So please don't. Just don't. Right? If you need that extra little bit of quirkiness, if you need to initialize 3 variables, you could do it. But is it as easy to read? I don't know. So think before you do anything outside of the normal pattern that we're using. Same thing with conditions. I can technically have, I'm initializing I and j in one go. And right here, j is less than 10 is the condition that stops this thing. I could have a bunch of conditions. I could have I is less than 10, I is less than 10, and j is greater than 4, right? I could have a bunch of conditions. It's just something that resolves to true or false. I is less than 10, it's a true or false statement. I is strictly less than 10, true or false statement. I is not equal to 10, also a stopping condition. It's just any old any old condition, like I had with my for loop, with my while loop. It's the second of these things. So first is initialization, second is my stopping condition, and then the third is my update. So, by the way, I thought I was going to jump to the update here. See through the examples that long initialized values and conditions support each other than if we don't have something where the starting condition, the stopping condition, and the update, if they're not working together, if I have i's in some cases and j's in other cases, which have been a problem for me, I have a variable j, but I forget to change this to being a j instead of an I can get an infinite loop still. So what our requirements normally is, I have something to start the loop, and I have something that's going to increment each time. And this condition here, all it states is the conditions that get me to stop the loop. It doesn't say it has to stop at a particular position. It just says, what are the conditions that will make this thing stop? It just happens to normally be that it, converges to some value. It's like normally counting up. But by the way, it could count down. I could start at 100. Here's an example. Start at the value 100, and as long as I is greater than 10, I keep going, and then maybe I minus, right? I could count down as well. Nothing prevents me from doing that. I can count up, I can count down, I can jump by 4s. It doesn't matter. It's just some condition that I have. And element 3 is my update. And that update, it's at the end of the loop. After I've done one execution of my loop, I will do that. Only after I've done one execution of my loop. And it will do each time through the loop, I will do this update. And normally should get me closer to the exit condition, right? I'm getting closer to the size of my array. I'm getting closer to 10 or whatever. I'm trying to get closer and closer to what will stop my loop. And if I'm not smart about it, I can get bad things can happen here. But and you could do anything you want. Normally it's I++, but it could be I times it could be I squared for all you know, right? So I can do things like, here's our standard example, I++. It could be I is equal to I plus 2, right? Incremented by 2 each time. It could be multiplied by 3 each time. Notice what happens here if I multiply it by 3. 0 multiplied by 3 is, 0. I'm not getting any closer to my stopping condition. This will not converge as a result. This is why you don't get cute. I could start 100, go to, but not include the 0, I minus. If I have an array with 100 elements, I'm out of bounds here, and I'm also avoiding the very last element, right? You got to think it through before you start. This is decrementing I by 22 each time, right? Keep it as simple as you can. Don't get all cutesy with it. You should be able to read these weird for loops, but I would stick with the standard pattern that we have whenever you can. All right. So here is my for loop. I have 2 for loops in here. Just like a while loop, if I have a single line, I don't need the curly braces, but I should always put them in. Why? Because I actually intentionally put in a bug here. Can you notice it? Well, hopefully you can notice it. It's the one in the different color. What does this do? I'll wait for a second. What does this do? It should go through from 0 to 100, but not including 100. So 100 elements starting at 0. It's going to be enemy number 0, enemy number 1, enemy number 2, enemy number 3, enemy number 4, all the way to enemy number 99. And then afterwards, that's the end of my for loop. Then I will print off, notice the bug, one time after I go through 100 enemies. This is actually not part of that for loop. It looks like it is. It's indented like it should be, but there's no curly braces, so it's only the very first line being in that for loop. This is actually meant to be out here. So I will do 100 enemy number statements, one statement saying notice the bug, and then afterwards I will do 25 iterations from 0 to 24, where I say move the plant, and number of points is plus equals 27. So I'm going to increment the number of points by 27 each time through the loop. So it'll be 27 times 24 points plus whatever the number of points was beforehand. And I will move plant I, so plant 0, plant 1, plant 2, plant 3, up to plant 24. I will move each of those 24 plants one after the other. That's what these two for statements are. What is it meant to be? This is actually an example from way back. Audrey was obsessing over Plants vs. Zombies. In case you see a lot of zombie examples, I kept a couple of them in there. So this is moving the plants in the game Plants vs. Zombies, in case you're wondering. All right. So I would like you guys to try and write a program that prints every third number between two numbers in the program, like you did before. Just like you did before, but this time use a for loop. And how would you do it? You can even get a little cutesy with your format of how the for loop will actually work. That's fine. You don't have to do the I++ only version for this. So try that out. If you can write this program, if you can write the for loop that does this, you have a pretty solid understanding of how for loops work. All right. And let's see here. So we have two numbers that we're entering. What if the min is less? So try it out, by the way. If you didn't already, I'm going to go over the answer right now. So you put in two numbers. I find out if the min is greater than max, I flip them around because I always want the max to be the actual maximum value. All right. We could have also used a ternary statement. Could we use a ternary statement? No, we'd have to do this temporary variable thing. So I find out that the minimum, I make sure that the minimum is strictly less than the maximum after this. So maximum is greater than or equal to the minimum. And then I'm going to print off these numbers starting at the minimum. I is equal to the minimum. I stops when I is greater than or equal to the maximum. So I'm not including the maximum in this case. I could put an equal sign in here if I wanted to include the maximum. Every time I'm done the loop, I is equal to I+3, and I'm printing off the value I. Looks just like the while loop. It's just a slightly different format. But it should do the same kind of thing. Okay. When we're talking about loops, we have a couple things that are very, very common. First of all, everyone screws this up. It's very common. You'll see a lot of, I'm going to erase it afterwards. You'll see a lot of people do this kind of thing. They'll put the semicolon there because they know they have a semicolon that's missing somewhere. And they go, well, let's put a semicolon on each and every line. And they'll put it on the for loop. No. There's only one place where you have the semicolon at the end of your looping thing. And that's really actually for the do while loop, right? At the end of my do while loop, I have a semicolon there. So that's a very common mistake for people to make. Number two is infinite loops. If I don't increment my I the right way, or if I don't change the thing, if I'm not converging towards some stopping condition, I'll get an infinite loop. So if you do it intentionally. Don't do it by accident. So always look at your functions or your loops and make sure they're getting closer to that stopping condition. And most of the time, it's just people forgetting to increment or decrement the counter. And the other one is that they will use a floating point number as my loop counter, like float v is equal to 0. We'll stop it when it's exactly equal to 4, v++. So we start at, let's say, well, we'd start at 0 if we wanted to. But v might get close, but not exactly equal to the value 4, and I have an infinite loop again. So this is why we avoid floating point numbers and doubles when it comes to stopping conditions, because it gets close, but not exactly the number that we're looking for. Okay, so I would like you to make sure you guys do a little bit of practice. The assignments should give you plenty of practice with while loops, do while loops, and for loops. Those are the big foundational things that we needed. We're going to look at structs next, but until we got to loops, we still had to, it was a hard time finding good examples. Now that we have loops, we can almost do anything we want in computer science, like for programming. We can do some really interesting questions now. And so hopefully the assignment will actually give you lots of examples, lots of practice on how to use these three different mechanisms. All right. Thank you very much, everyone, and I'll talk to you soon.